Hey there again, Bob here with JD Squared. Thanks for tuning in. Hey, the last video we did, we had cut out the fancy square tube, and this is another request I've got from people, and they want to make a tube wrap. In other words, they want to cut out a section of the tube so that they could place it onto their metal and then weld it or rivet it. So I'll be showing you how to do that in this video. Now, when I took this back to grind it, my welder goes, why don't you just put a couple holes in it, we'll put a rivet in it. So we're going to do that. But what I'm going to go ahead and do is I'm going to do it in 3 parts. I'm going to break the video down. I use Autodesk Inventor. I used to use Solidworks for 23 years. I switched over about a year ago to Inventor. While I'm modeling it, I'll tell you kind of why I did that. But anyway, this was modeled in Inventor, and then we brought it into CamALot. We set up the cut profiles, came out here, and you could see where I have cut it right here. So I'm going to do it in 3 parts. First part, I'll just quickly go through Inventor. I'll put time tags at the bottom of the video so you can just skip past the crap you don't want to see. The second part will be me, as usual, loading it into CamALot, because that's the purpose of these videos, is to kind of show you, start to finish, what you got to do. And then the last part, we'll come out here and we'll cut this tube out. So let's head on in the office, get after it. As I mentioned earlier, this is going to be part 1 of 3. This is going to be the modeling part, and I'm using Inventor for this. You could be using Inventor, SolidWorks, Fusion 360. I'm really high on Fusion 360. I love Inventor. I was a SolidWorks user for 23 years, and real quick before we start, we put in a second laser and a second high precision press. Well, the press had different V tooling and everything. And unfortunately, SolidWorks made a decision to store all of the sheet metal parameters in each individual part file. Now that works okay, I guess, if you're sending part files to other companies. But in our situation, it was a nightmare, because with the second press, that meant I would have to open every single part, save a copy of it, and then put in the new K factors, the new bin parameters of the sheet metal. And combined with the last few years, it's just been, SolidWorks is crashing on me nonstop. I mean, literally 8-10 times a day. I sure hope they get that problem worked out one day. But anyway, the bottom line is, after 23 years, I jumped ship. I was tired of it. Went to Inventor almost a year ago, and I absolutely love Inventor. I did not know what I was missing. Inventor's great. SolidWorks is a good program. I wish them well. I'm not putting it down, but I just had problems with it. Anyway, real quick, let's go ahead and model this bad boy in Inventor. So I'm going to go ahead and do a new part, JD squared sheet metal. Now, the wall thickness in 1.5" pipe schedule 40 is 145. I am going to go ahead and select 10 gauge from the drop down. How nice is this? Inventor, golly, it's so nice. Anyway, we picked 10 gauge because it's 135 wall. It's only 10 thou difference. It's not going to be a big deal. Let's go ahead and pick ourselves a plane that we want to work on. And once again, I'm not teaching you how to use a CAD program. They all work similar. Now I'm going to go ahead and set the height of this slot at 2.5 inches. And the reason is the circumference of the 1.5 inch pipe is just under 6 inches. Let's round it off to 3 inches. And I want this wrap to be able to drop onto the tube. So I don't want it wrapping around the back side of the tube. Therefore, the height of the wrap needs to be less than half of the tube. So I went ahead and I picked 2.5 inches. Let's go ahead and set this length at 2.5 also. Notice it just went black, and it says down here fully constrained. I'll talk about that in a minute. Just what the heck, I'm using a program. I can tell you what I'm doing. Let's go ahead and assign that as a face. And there's our sheet metal part. That's going to be the base of our logo. Now what we're able to do in Inventor, SolidWorks, you could import a DXF. You could do the same thing kind of in Inventor, but they've got a really cool solution called iFeatures. And I created one a while back. You can see it, the JD squared logo there. But I actually created this logo for 4 inches and larger. I didn't really create it to go down to a 2-inch size, which is what we just did there. Now, when I did that, this area right here got very, very tight. I mean, like 30 thousandths wide tight. Now the RC6 cut it fine, but I ended up with a little bit more slag, a little bit more dross on the bottom that I had to drag off. If I was doing a lot of these, I would probably give myself a little bit more clearance here when I created the logo. Now if you notice the logo is off center, not a big deal. We are going to edit the sketch. Remember the logo is 2 inches tall. The slot is 2.5, so I am going to set it 2.5 inches from the bottom. Notice it's purple. That is common between most CAD programs, and what it is, it's telling us that it's not fully constrained sketch. In other words, Inventor will put it down for you, but it's not 100% defined. So we're going to define it. We're going to constrain it. We're going to say this is 0.1 inches from the end. Now notice it's gone black. Now it is fully constrained. In fact, it tells you right down here, I'm fully constrained. All right, let's go. There's our JD2 logo. Let's go ahead and add the pop rivet holes that my welder suggested I do after I showed him the first one I did. I am going to go ahead, and I'm going to show you a couple things. I'm going to go ahead and drag these holes around. In Inventor, you could project geometry. So we're going to project the y-axis. You see the line, the yellow dashed line right there. SolidWorks doesn't do that. It does it another way. Both of them work great. We're going to go ahead and make both of these holes equal in size. I'm going to go ahead and tell it I need this hole here horizontal from the middle of the slot. Now I want to make both holes symmetric about the center line axis. Now we should just have to be able to put in a couple of dimensions. 3.5 for the spacing. That looks good. Let's put the hole diameter at 1.8. Notice they both gone black. I'm fully constrained. I'm done sketching. Now I can come along, go back to sheet metal, cut, cut, cut. I'm good to go. And there's our part. We're finished. I can go ahead and save this part. I did it earlier, so I'll overwrite that one right here. Let me show you something in Inventor that I really, really love. Let's just say I wanted to go ahead and make this part out of 16 gauge metal. Watch what's getting ready to happen here. How cool is that? Just lickety-split quick. That process is much, much more complicated in my previous CAD program. Anyway, the last thing we need to do is we have to save the face as a DXF file. So I pick the face, I'm right clicking, export face as tube wrap right here, JD2 DXF. Save that. Of course I'll replace it because I created it earlier. Didn't have the holes in it, but now it does. That's it. We're done with Inventor. Let's go ahead and move on over to CamALot. Well, it's CamALot's turn. First thing we're going to want to do is go ahead and create our tube. So I select Create Frame right here. Now, if I notice my profile, my active profile, which I'm going to create this tube out of, is set at 1.5 OD. So let's go ahead and select a new profile. And we will select our 1.5 pipe, 1.9 OD, make that active. Let's go ahead and add a tube. We're going to start where we normally start. Right here at the origin, we're going to add a point. Now I'm only going to make this tube 5.5 inches long because the part we're cutting out of it is 5 inches long, and this way we're not using a lot of tubing. So let's go ahead and we'll hit enter. There's our tube. Let's close this, apply and close, and that's our finished tube. The next step is to create a job for this tube. I'm going up here on the ribbon and I'm selecting Make Job for all items. There's only one tube in it, so it's not a big deal. And it's asking me, what would you like to save the job name as? Tube JD2 wrap. And there we go. We have start cuts and we have end cuts. Now, this logo or this wrap that we're going to cut out of this tube, we cannot apply it at the tube level yet. That's extremely difficult to wrap and cut tube and all. Programs like Inventor can do it, SolidWorks, Fusion 360, but those companies have thousands of programmers, decades of experience. We're not quite there yet with CamALot. Hopefully, maybe next year we will be able to wrap it on it and you actually see the finished part. However, we can still accomplish this at the job level in CamALot. First thing we need to do, obviously, is bring in our DXF. Let's go up here to Text Contours and select DXF and Text. Import the DXF file. double click on that DXF that we created earlier, and it just brought it in. Now, if you notice, it's on one side of the tube over there. Let's go ahead and hit center X, center Y. Now you can see where it's been superimposed on the tube, and we have a little flat representation of the original part. We need to go ahead and apply this to all cam items. Now you can see it where it's gotten rid of the flat. It has basically placed it onto the tube. Let's go ahead and close that tool right there. Now we have to create operations to cut this out. First thing we're going to need to do is create an operation to cut out the part, right? However, CamALot is going to look at this whole structure and say it's inside of the tube, therefore it's a hole, and it's going to want to place the kerf and the lead ends inside the oval. We don't want that. We want to keep the oval and cut out the JD squared. So what we're going to do is move certain parts of the wrap to their own individual layers. And the part that I care about is this part right here. So I selected it with my left mouse. I'm going to right click, move contours to new layer, and I am going to select new layer right here. You can actually see JD2 wrap right here. That was the entire DXF that we brought in. Let's go ahead and create a new wrap, and we're just going to call this outside. Sweet and simple. All right, there we go. Now if we pick the JD2 wrap layer, notice that only the JD2 and the rivet holes are being highlighted. The outside is on its own layer. Now we can go ahead and create operations for this part. I'm going to want to create the operations in the order that I want them to happen on the machine. Now, I could easily drag and drop and reorder them, but sometimes it's just easier to think like that. What do you want to cut first, then next, and then the final cut? Well, first thing we're going to want to cut out is the JD2 and the holes right here. So let's make an operation for that. And we're going to select the JD2 wrap. We're going to leave the kerf width and everything by itself. CamALot has looked up the speeds and all. And we've got 45 amp shielded in the machine. That's what's selected. We're going to say OK. Now, I'm going to show you a change that we're going to have to make. If we zoom in, these arrows, these little lines right here, are your lead ends. That's where the torch is going to blow a hole right here. It's going to feed with the arrow here. It's going to start cutting in this direction, end up lead out over here. But look over here what it's done. If it blows in over here, it's going to blow outside of the boundary of the number 2. Therefore, we need to shorten these lead ends a little bit. So I'm going to double click on the operation. I'm going to come over here to lead in, lead out, and I'm going to shorten them. Let's go see what maybe 70 thousandths of an inch looks like. If you're using metric, I could click this button right here and switch over to the metric system. Anyway, we got 45 amp shield. Let's go ahead and click OK. Did you see it just drop back? Which means we can now cut that part no problem. Let's go ahead, and even in the holes over here, you can see where we're going to blow into the tube here, cut that way. We're not outside the boundary of the tube. So that has been fixed. The next thing we need to do is go ahead and make a layer to cut the outside of the wrap. Not a layer, make an operation. Let's go ahead and we will select outside. But this time, well, let me show you what happens if you leave it on a normal offset. If we click it like this, and we've got our operation, if we go over here to the operation and we zoom in on it, in fact, let me turn on unfolding. I think you can see it better with the unfolding. Let's go. All right. You see the black arrow line there? That is what the torch path is going to be. But the actual wrap is the cyan around it. Well, the torch is on the wrong side. So we're going to go back over to our operation and we're going to tell it flip the offset. Let's go ahead and say OK. Now look what we've got. The black has moved to the outside because we're going to retain this inside. That's the part we want to keep. Now, there is one other issue, however. When we flipped it to the other side, CamALot left the lead in and lead out on the inside. So what she's going to do right here is it's going to blow a hole in our wrap and then go out and cut to the outside. That's not what we want. We need to flip these around to the other side. To do that, I'm going to go up here to Edit Contours, and I am going to select my outside layer, and I'm going to hit the button select by layer. Now all of these become active, and if you look at one of the panels, it's rotation of leads. That's your lead in and lead outs. We want to rotate these to the other side, which means we got to flip them 180 degrees. So let me go ahead and type that in, and now I could rotate. Now look, you can see right here, they're coming in towards the JD2. Let's rotate them. And I can move that over, and now they've popped to the outside. That's exactly what we want to do. That way we're not going to be blowing holes inside our tube wrap. Let's go ahead and close it, zoom out. Now one other operation I like to add is an in-cut operation. Let's go ahead and select our in-cut layer and hit OK. And that's this in-cut here. And the idea is we want to cut the wrap out and then come back and cut the tube off so we're not left with a tube with this gaping hole in it. We have a clean end on the tube. Alrighty, at this point we are now ready to nest our tube. So let's go up here to nesting and select that. I'm going to leave the raw length at 36 inches. I've talked about this in previous videos. We're going to set the program origin to the end of the tube, so it makes no difference what we enter here, just as long as it's longer than the piece that we're cutting. I'm going to leave it at 36, and I'm going to hit Nest Tubes, and there we go. That's our operation right there. The next step is to run the post processor, which will generate the G code that will be taken out to the machine to make this part. It asks us, what do you want to save it as a name? I've already saved it earlier because you saw a part that I had made. Tube jd2.wrap.ngc. That's the numerical G code. So let's do that. Do I want to replace it? Yes, I do. Now, if I select G code down here in the lower right, this is all the G code that we're going to copy that file onto USB, take it out to the machine, and cut it. However, there is one other thing that I like to do, and that is verify that I've done this job right. I've got the parts in the correct order that we're cutting them. The lead ends aren't going to be blowing holes where I don't want to punch a hole, things like that. In order to do that, just go up to Animate up here. That'll bring us to this here. And I could hit the animate button and we'll start animating. However, it's not in a giant hurry. It's cruising along. So I'm going to stop it. And what you could do to speed that up drastically is just click over here with your mouse, and then I'm just going to hold down the down arrow key, and you can see how much faster it's running. Later on our roadmap, we have plans to have basically a gas pedal up there. How fast do you want to do this? And we'll be able to do it. Now, what I'm looking for is things like this. Are the lead ends in the middle? Are they going to blow into a part of the tube that I'm trying to save? And you can kind of see that they're not. It's looking really, really good. Let's continue on. And I'm also looking at the order of cut. So I've cut my holes. Now I'm going to cut the actual wrap out itself. And finally, we're going to cut off the end of the tube. Now, let me zoom in right here. See where we flip those lead ends to the outside so that we don't cut into our wrap? That's what I'm doing right here. Anyway, let's go ahead and put the file on the USB and head out to the machine. We're back at the machine right here. And I've gone ahead and I've set Y0, the origin point of our program, to the end of the tube right here, actually just inside it a little bit. Now what I'm going to do is an operation called dry run. That's where you tell the machine, I want you to start the path motions, but I don't want you to turn the torch on. And the reason I'm doing this is because inside of our tube in here, we have a seam. And I don't want that seam to be in the middle of my wrap. So I want to kind of verify that where the machine's going to be starting to cut, the seam is on the other side. So all I'm going to do is turn on dry run right here, and I'm going to hit run. Now you hear a little squeaking noise. I need to spray a little bit of lube on the lead screw. You have to do that, once a month, something like that. Take the top off here. It's easy peasy. Alrighty. So let's take a look here. Okay, the seam is right here. Actually, I can see it. So we're good. I'm going to go ahead and stop the dry run process. There's no point in continuing on. Now I'm going to start it for real. Let me go ahead and reposition the camera though, because a lot of people tell us they really like to be up close to see what it's doing. Let me go ahead and do that. Let's start by turning on our through spindle coolant and hit the run button. Now, I've got a pair of needle nose right here because what we're going to have to watch out for is the letters kicking up. So what I can do is as it's cutting, if I see a kick up, I will just hit the pause button, use my needle nose, remove the remnant, and then continue cutting. So that's what I'm looking for right now. You can actually see one right here. We're going to hit the pause button in a minute, right after it cuts out the J. All right, let's hit the pause right there and remove. See the little part right here? That's what we want to remove. There we go. Alrighty. Continue on. When you're doing intricate work like this, you really got to watch for kick-ups. Here's our finished part cut out right here. I kind of made a mistake. I hit the stop button on the program. I didn't let it actually cut the tube off. Oh well, my bad, no big deal. Anyway, this is our part right here. We got some slag on the inside. Yeah, I could break some of it off with my finger. However, what I found is by using a file, I can just knock most of it off. Now what I'm going to do is I'm going to go ahead, hopefully you could see the inside right there. You get a little bit of slag on this because we have a lot of fine detail right here and we're putting a lot of heat into the part. That's what happened. Let me go over there into welding. I'll take a grinder and I'll bring it back and show you the finished part. I'm walking over to the laser area to grind this part down so I can show you the pretty version of it. And I hear the laser operating over here. And I thought, you know what, I'll take the camera over and I'll maybe see if I can get a shot of the laser running. It's after 9 o'clock at night. I'm the only one in the building, but the laser has been running about since 4:30. Let me flip the camera around and you can see what it's doing. This is our 6 kW fiber laser, a model. This is the one we added back, I believe, in November, December, in that area. And it's been cutting on this job now for, I guess, about 4 hours. This is 1/2-inch plate, and there is a ton of little parts in there. Let me zoom in there. This is one fast machine. When she rapids, it is not joking around. See that? It's already getting ready to cut, pierced, and there we go, we're cutting. Anyway, I just thought you might think that's a little bit interesting. Let me go over there and I'll cut this part and I'll get back to you. Well, there's our finished part right there. I grounded it inside, I ground the outside. And the idea is we can place this now on an 1.25-inch pipe and you can see we've got a nice fit. And we have the JD2 logo that we could pop rivet onto this tube right here. Anyway, that was a project that several people have asked me to do. Hope you enjoyed it. Please subscribe, stay tuned, and let me go get started on the next video. Thanks a lot for watching. Goodbye.